Now another feature, if you'll take a look at the screen, there's a lot of columns on this screen to deal with. You can customize your view by simply right-clicking on the top of each one of these screens, and you can see all the different options available for viewing the columns. So depending on what you're using at this time, you can customize this. If you don't need to look at the if you're not using arrays, for example, you can choose to not look at the rows or the columns, and then you can select the choose column option and customize this. So we will get rid of the rows and columns. We want to keep our system IDs and type. We don't need the number of characters. We want to keep retentive and initial. We don't need our wiring values. We're not using Modbus at this time, so we can get the Modbus starting and end address. We will keep the initial force, enforceable, the comment, default formats, and in use. So we will say OK to that, and we restructure. And you can resize these as well. We don't need a comment. You can add comments there. The in-use column shows you which tags in your tag database are currently in use in your project. The default format column is used with integer tags. Integer tag, it shows you the default format for that integer value. Again, show all. This is a filtering device that's enabled at the top of the screen, and the tags to show in the editor. So you can select and deselect these as necessary based on what you're searching for. And this little insert button is very convenient if you're searching for just floating points. You can deselect that one and then invert, and now then you see only the floating points. Again, you can do multiple ones. You can look for as much or as little as you want. Again, or show all. And you can also filter by text. Let's say we were entering new tags. You start typing into the edit field of your filter. As you start typing in a tag name that you're looking for, and it will pop up. I know I've got a log data tag. Log data. We've got a bunch of discrete inputs, DIs. We'll look for just DIs. So this is a nice option. Let's go back and show all. Data view window is a very powerful window and one that's used quite a bit in troubleshooting and commissioning systems. And what we're doing with the data view window is giving you an option to create a tool to view the status and edit the status of any given tag. So in this, we have multiple tabs at the top of this one, so you can actually you can add a new data view at any time and add the tags that you need. This is saved with the project. So anytime you save this project, this data view window with all the tabs that are associated with it will be saved. The next time you bring the project up, your data view windows will be available. The forced tag and data view 1, you notice, do not have an X by them. All the other ones have an X by them. Those are two tabs that cannot be deleted. You've got to have at least one data view tab available at all times. And then the forced tags tab is created for you out of the tag database that we were just in. So if you go back to your tag database and you look at your, I've created some tags that are just called force tags. And you will notice that these are selected as forceable. We've created some tags that are just called force. And these tags, we've got them set as forceable, and some are initially forced, and some have an initial force value. But any tag that is set as forceable will show up in the data view window under the force tags. So if we take a look at our table, scroll down to the bottom, and we come into our tag database and we select a new tag to be forceable. Let's take a look at our discretes, our booleans. and I will set call sign as forcible. Now you'll see that call sign has been added to the data view window under the forcible tags tab. And as long as that tag is selected as forcible, it will show up in the forcible tags window. Any tag that is removed will remove call sign, and it is now removed from the forcible tab. And we will take a look at our task management screen. In the task management pane, you will see that you've got a task. This is where we've taken our projects. You can organize these by task. So now we've got multiple actual mini programs that we're displaying, and they've got different sections of code in each one of these projects. These projects are organized under the task management window. So we've got our main control, and our main control is under Run Every Scan. Under the Tasks folder, you've got a Run First Scan Only. This is used mostly for organizing and configuring data within your project. And then we have a Run Every Scan. Run Every Scan is the project that you want to do the main execution, and it will scan every single. It will execute every single scan. Now, you may have very little in the Run Every Scan task. This may be a project that does nothing but call other tasks, and so you'll see in the main control program, I've got this set up where I'm actually calling. I'm not going to be adding any instructions, so let me increase my view here a little bit so we can see this a little better. So we've got a call task on the first two lines of our main control. And what this is doing, this is calling sine wave, which is in one of our run when called task folders, and a scale amplitude, which is also in one of our run when called task folders. So these are two separate programs that are sitting in a run when called folder, and they're going to be sitting dormant. They're not going to be scanned at all until these conditions are met. Once these conditions are met, we will call that program and we'll run it, and we will continue to run it until we exit the run when called, or until this condition becomes false. We also have a Run Every Second. In the Run Every Second, we will execute whatever is in that particular folder once per second. We will execute it one scan once every second. We'll take a look at that right now. We've got a flasher program in here that's going to a relay output that you should hear ticking in the background right now. This relay output is in the Run Every Second folder. However, the flasher is set up for a 50 millisecond flash rate. So even though it's set up to flash every 50 milliseconds, we only hear the audible of the relay cycling once every second. It's because it's only scanning one scan every second. So if we take that same folder, this toggle output, and we move this up to Run Every Scan, and we do a runtime transfer, I must have made it. Oh, I made a change to the hardware configuration. It's going to do a stop mode transfer. So it'll stop for a moment. Now we'll go back to run. And now you will hear the toggle output. Oh, I made a hardware change. This thing is smart, believe it or not. This hardware configuration, I added modules to the configuration. I added a base and modules to the configuration, and so when I made the transfer of the project to the processor, tried to go to run mode, and it noticed that my configuration didn't match. If I would have set this module in this base for no verification, enable hot swap, then it would have continued because the system would not have cared if it was there or not. But now then, it cares, and that is the default. So we will read the configuration, and it's actually going to come up now, and you will see this bottom base. It's going to come up and tell me that there's a mismatch and ask me if I want to, we've got a base mismatch. The physical I/O is missing in the base, and it's going to ask me if I want to remove the base. And I'm going to say yes to all because it will ask you for everything that's, it'll ask you this once for every component that is incorrect. So I'm going to say yes to all, and this will get us back to our original two-base configuration. So now then, all right, my toggle output is still up in every scan. and I can switch to run mode. Let's try that again. Oh, I didn't. Jeez, you got to transfer. Okay, so now we'll transfer our project. We've corrected the hardware configuration. We've transferred that down to the CPU, and now then we're back into run mode. What you hear now is the 50 millisecond flasher rate from this output. So we will take this output that's now running and being scanned. It's running every single scan. We'll take this same file, bring it back down to the run every second folder. We'll do a runtime transfer, and as soon as that's transferred down, you'll hear that frequency drop down to once per second. We can take that same folder and drop it down to our last folder, which is the disabled task. This disabled task folder does exactly what it says. It disables anything that's in it. So if you drop a file into the disabled task and then transfer your project, that file does not get transferred to the CPU. So we will do a runtime transfer now, and our output will stop completely. So now then our output is no longer being scanned at all. It's that simple, and which is a very good troubleshooting tool. If you've got your program divided up and separated into the tasks as you need them, and separate those out by sequences in your process, then it's very easy to use this disabled task to troubleshoot your program. It's also very useful for system integrators and OEMs who have machines that have multiple components, and you may sell a machine or set up a machine in various configurations. And so if you've got a machine that may have 12 total units in its largest configuration, but you may also sell that system or configure that system that may only have 3 units combined or 6 units combined. And you can take, if you've got your program divided up and if each unit has its own task, you can separate those out and pull them into the disabled task folder if you're not using those in that particular program. So we'll take our toggle output and we'll put it back up to the every scan.